welcome back to class.
Thank you.
What was the homework that we had for Friday?
Oh, I finished it.
It was 2 pages, my girl.
It was
Yes.
page
22 and
22
23.
and
It
23.
was 22 and 23, which we are going to get to, but we skipped page 21 because we were going to start class with that. So yes, our advice for geometry is to use a protractor that you can see through. One of the clear ones is best. That way you can see exactly where your line passes through, depending on which one of the numbers you need. You may need the smaller side, because you always start with what? You start with your zero. You start with your zero side. All right, on page 21, construction number 7 is the example that you have to refer to for what we're about to do. You need to learn one more construction that deals with perpendicular lines.
That means like that.
What is a perpendicular line?
Parallel-ish.
All right,
It's
It
lines that intersect in
all right,
usually at the midpoint, but it doesn't have to be there.
okay, okay.
And they create 4 angles.
4 angles.
Yes.
Like 90-degree angles.
90
Like
degree
90
angles.
squares.
Right angles.
Right angles, good.
Outside.
So if we left out any of those steps, Hannah, if I had a line and I had a line that intersected it, is that perpendicular?
No.
No.
It's not perpendicular.
Intersecting.
The only way it would be perpendicular is if I was up high
At
from
an
some
angle.
angle looking down and this was a flat plane. This just happened to look that way. So my perspective was way over here, up high looking down on it. And that they might actually be. That could look like this. From straight over. And then if I tilt to the side and look at it, it would look like that.
Wow.
So perspective matters, but for now we're not doing a study in art in perspective just yet.
Oh. Can we do that though?
So our first assignment then is, as we're on page 21, it says number 1, construct a line that is perpendicular to the given line at a given point. So you have 2 things that are given. Your given is a line. That's our straight line. And then we also are given a point on that line. Now the point they have, it does appear to be kind of sort of towards the middle, but it doesn't have to be. Then the one for number 2. So you could pretend this is one for number 2. It's not in the middle, it's slightly off to the side. So there's our given point. So we're given 2 things, a line and a point. And our instructions are, our goal line, our therefore this is done. How do we know when we're done? We're done when we know that we've constructed a line that is perpendicular to this line. Now we can make a line that's parallel, we can make a line that intersects, but in this case we need to make one that's perpendicular. How would we do that?
Okay. Do you want me to walk you through it?
I can do it.
Our first step,
Yeah.
do you have hopefully a much smaller compass? This one is enormous. Yeah, because it did tell you to make a line.
Right. No, I want to
So a
say.
line is perpendicular.
But does it go through the?
It does. So for this to work, you have to make a defined point somewhere that you can stick the pointy end of your compass as a reference point. That's a lot of use of the word point in here.
Yes, we got the point.
Got the point. Nice. So our first step, we created some points, so points of intersection. We labeled those D and E. From there, the pointy end of your compass goes at that point, and from that point, you bring it up and make your intersecting arcs. We've already made some of those intersecting arcs before when we were bisecting a line, when we were bisecting an angle, when we were drawing an angle that's congruent to another angle. We've done all those things. So that gives us 2 points. I have a point here, point C.
I don't get your point.
And then I have another one, point F, which occurs right there where they intersect.
You could erase the no dot I did.
Yeah, I mean, you could have other dots on here, but they wouldn't really mean anything. So we've got this line here. So she drew a nice straight line using the straight edge. And we've got this really long line. Now, it doesn't really matter how long you draw it? Question mark? Does it matter how long you draw this?
Yes.
No, it can go on
It
forever.
matters.
It really doesn't matter.
Mean
I mean,
that
you have them inside the paper,
regardless,
but you
they're
want
just
forever.
invisible after the arrows.
At a certain point, you run out of paper, basically, and that would be sort of your limitation, unless you were drawing it on a much larger sheet of paper,
Or drawing it in your mind.
or you're picturing it. I suppose
Yeah,
that could work as
picture-
well.
If you picture it, it goes all the way around the world.
Yeah, and then it comes back and,
And then
it's just a circle.
Okay, so those are our steps for problem number 1. Problem number 2 is the exact same thing, only they just moved the line on the paper. But if you take your paper and twist your paper, you have a straight line directly in front of you with which you could also draw a perpendicular line.
Wait, are we supposed to do it on one and two or just one?
So we're just doing one, and now we're going to jump down to the next problem. Our next one brings together a number of things that we've already learned in our constructions. The directions are, now we're on number 3. Using your, what's the first thing we've got to use? Protractor. Draw an angle below, and it gives you a specific measurement it wants that angle to be.
100.
So your first thing you must do is start with a straight edge. And do your very best to draw a nice straight line.
I did a very best line.
Wait, wouldn't that actually go array
That one's slanted.
since it only has...
Yeah, it may have a bit of a slant to it. It just needs to be straight. Because you got to have a starting point, and you're allowed to do that with the straight edge. And this is our beginning. This is our fixed line. And then I pick some arbitrary point here, and I can label that John C. You can label it anything you want.
I said label it B.
Yeah, ABC.
Unless it gives you specific instructions.
You're a bad math teacher if you don't like this one. Alright.
So if you follow instructions, then you would be labeling it B. Why would I label it B? How did you know that?
B's in the middle, so that's
B's in the middle of what?
Your mama.
of the ABC.
Of the ABC.
The
Yeah.
ABC, yeah.
Because it said,
Yeah.
construct an angle that's 100, and it labeled it for you, ABC. So this has meaning. The B is called the
Midpoint thing, whatever it's called. Axis, no, what is it called?
Vertex.
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 I was trying to, oh, it's close. Okay.
So B is called the vertex of the angle. So I would label that B because it's in the middle. There are other ways you can write the vertex. If I had an angle already drawn for me, right here, I could label this B, and that would be a way of labeling the vertex. In your construction, it may be part of something else, and so you might just have a 1 there. You might have an angle 1. And that'd be the vertex. Instead of a 1, maybe they use a small letter B. So there's a few ways you can label your vertex. In this case, they gave you the capital letters, so you can label it with a capital letter, a small number, small letter, or you can write all 3 capital letters identifying your angle, and the middle one is the vertex. There's different ways you can do that. All right, now we've got our good starting point. So it does tell us to use a protractor and draw an angle with a measure of 100. 100. Now, how do I do that?
Oh, I did that already.
Yeah, we
Yeah.
did it already.
You're already ahead of me. So you take your protractor and you line up the dot, the vertex B that you created, that point, with the plus sign, on your protractor. And then the line itself needs to go straight across directly through the 0. And using 0 as my starting point, I go all the way around, so I'm getting bigger. 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 100. So my 100 passes right through there. So I made a little mark where I found the 100. Now why didn't I make a mark right here? This says 100.
Because it's
That's
the
because it's
is,
less than a
that is
90-degree angle. Yes, it's less than.
Yeah, if I made the mark here, it would be what kind of angle?
80.
It'd be a
Acute. No, acute.
It would be a acute angle, but it'd be wrong. Oh.
It'd be the wrong angle.
You're right.
Because
But
it would
even a
be
right angle would be wrong.
it would be less than 90, and you'd be marking that 100. It can't be less than 90 and be 100,
That can't.
right?
Are you stupid or something?
We still have the law of non-contradiction working on our side.
Wait, that's a law.
You may have only made one mark. I made 2. It makes it easier to ensure that I'm getting a pretty straight line. Okay, so that is my angle. And this distance here is what? 100? And I'm supposed to label it A, B, C. So I generally just choose points somewhere out towards the ends. That's fine. It could be anywhere. But this is a way of labeling A, B, C.
That angle looks beautiful.
The next part, it says construct an angle that's congruent to it. How do I make an angle that's congruent
You get out your handy
to an angle?
compass.
Hey,
Get out your ruler. Or your straight edge.
compass.
Yes,
Your
compass.
compass.
Well, first you have to make a line.
Well, yeah, you
No,
can use your
but
straight edge to make a
It's
line.
assuming you already have enough common sense to make a freaking line.
Because using your compass would be too easy.
So we did step 1. Next we need a congruent angle, congruent to ABC, and it needs to be labeled
XYZ.
XYZ.
With Y is the vertex. You get it? Y is the vertex.
And then finally, we need to bisect angle XYZ. Alright, so there's our 3 steps to this problem that we're doing. So we did the first one, and we have these other 2 still to do. Alright, so our first step is to create another straight edge line. Since I'm limited on board space, I'll just do it right here. Alright, so what is the first tool I need to reach for? I made my straight line.
Which one is it
Protractor?
called?
I would not use my protractor
That would be cheating.
when I'm creating a congruent angle. You can take your protractor and just throw it away.
You should have actually thrown it.
Sounds like
They probably broke.
I could have, like,
I really don't want it to break.
I could have edited an explosion. It'd be funny.
So our first step.
You would put your point
You need
on
help.
the B.
On B, yes.
Yes,
The
and
section
then
A.
draw a little hashing mark.
Good. On B? Why on B?
Because that's
Why not up
That's
here?
where it's gotta be.
Oh, you're
That is-
so funny.
It is where it gotta be. It gotta be right there.
See?
Okay. So then I take this and make this angle, or arc
That
rather.
is not right.
An arc.
Okay.
Wait, but it should be as
Now,
big as
I
it.
shouldn't move this, and I should go where with it?
To the,
To the
to the Y.
The Y.
Point to Y.
This is Y. So I put it on Y.
Could have been meant too big.
Make a much bigger circle.
The same thing.
Yes, there you go.
Okay. Now, I know that this and this, so the distance from the vertex B out to the circle at any given point would be the, what would we call that distance from the midpoint to the arc?
Bisect.
That would be the radius. Radius. So this, from point Y, this is kind of becomes the midpoint of this circle, or this arc, but if I continue to be a circle. So now from Y out to this point, any point on this is the same as here. Why do I know that? Because I didn't move my compass. It should be the same. If I moved it, then it would be off, and then the angle that you therefore end up constructing would not be congruent. So my next step, I go back to my original angle, right? Go back to here. And where do I put my pointy end of my compass?
On the point where it intersects.
On the arc.
Right there. Right
Why would I
there.
not want to do it up here?
You can do it on.
Wait,
Because
you
it's
already
not
have.
right if you do it up there because you have no place to start on the other one. You don't know where to start.
Oh, right.
You
Yeah.
can't do it backwards because it
You-
doesn't make sense.
So if I would do it like this, and then I came over here, I would still have to flip it.
Yeah, you
Yeah,
can
you
still
can
do it.
Oh, because it's so big.
So it would technically work, but I would say let's do it this way. So I'm going to reach out here and I'm going to make sure that it cuts right through that point of intersection. So my pointy end goes here, and then I made sure that goes through where the arc and the angle intersected, and I made a third line on top of it. So without moving this, if I did it right, it's going to go right here. This is going to make an intersecting right there,
That's not right. You should
and
Wait.
clearly it moved. But it shouldn't have moved.
Oh, I did
No,
that
you
wrong.
Yours will not move.
SB got a mustache.
Oh yeah, I moved it. Okay.
Hey, wait, are we both having this one?
If I don't move it this time,
Yeah, that's right.
Oh, yeah, I did that wrong.
Yeah.
that looks better. So you notice right away when I accidentally bumped it, it changed the distance. It changed my distance from here to there. It would no longer be the same. If I were to measure from here to there, that would have been wrong. It would not have been the same because I bumped my compass. So you got to keep your compass the same. That can get tricky if you have one of those that moves easily. The more you use it, it gets loose. Sometimes there's a screw on them, you can tighten it down. Or some of them you have a fixed little spinning wheel that adjusts the distance. Now what do I reach for?
Your straight edge.
I reach for a straight edge. That's what we're going to call it, not a protractor. Now I'm labeling this point here. What would that point become?
X.
X.
Point X. Sure, that's fine. What could this point be?
Y. A Z.
Z.
That was a 7.
And then I reach for a straight edge.
That's not a straight edge.
It's pretty straight. And then I line up the 2 points because I remember that 2 points in a plane form a
Straight line.
straight line. So I have now made this 100-degree angle has been duplicated over here for a congruent 100-degree angle that is now labeled XYZ. Congruent angle labeled XYZ. That's done.
That was a good check.
Yeah, that was.
Next, we need to bisect this. Now, should I go ahead and erase this arc? Because am I going to need that?
Yeah.
Oh, I need it?
Well, you might.
Yes, you need it. Sure, leave it.
Really leave it.
If I erased it, what would my first step be in bisecting an angle?
To drive
To draw it again. So my first step in bisecting an angle, if this weren't here,
Well, you need the 2 points.
No, don't erase it.
You just need the 2 points. As long as you have the points, you're fine.
Oh, okay.
well, the points don't matter either. My first step in bisecting an angle would be to take my compass. I would put my pointy end at the vertex. And I would come out here and I would make some
An arc.
arc of some distance. I've missed these points on purpose just to show those don't matter. The only reason they would matter is my angle is no longer labeled X, Y, Z. I can move my points
Their
right
lines
there.
are pointless.
But now, once again,
I just got that.
they have a point.
How funny.
It is funny.
It was.
You just didn't get the point of the joke.
Yeah, you didn't get that one either. Oh my god.
There was no point to that joke.
Okay, that's too far.
Now there are actually 3 points. Well, really I have more than that. I have those 3 points, and I have these that are now new points. So
What's your point?
Can you name whatever you want?
when I drew that arc, I actually made 2 points of intersection.
Jerry and Bob.
So whatever you wanted to label them. So I take this, now at this point I can move it again. But once I set it at a certain distance, I don't want to move it again. Because I do want to make it long enough though that I can actually pick a spot that's going to be a good bisecting area.
But Mr. Chris.
So you stick your pointy in there, and then make a mark out here somewhere.
Maybe you made it too big. Maybe.
As long as it's the same size, it doesn't matter.
So now I'm trusting that I'm not going to move it when I lift it. Sometimes that can be tricky, but it looks like it's roughly the same. Then I put it over here
Can't do roughly and speak exact.
and make this mark.
How is that straight?
Okay.
Oh, so when you're bisecting it, it's always.
Now what is it that we're doing again? We're
Bisecting.
bisecting this angle, XYZ. That's the third step for number 3. All of this whole thing is problem number 3. The whole thing. One problem.
Oh.
How
And
many of
then
these we have with us?
for homework we'll do 40 of these or so. That'd be okay.
Oh,
Just do
okay.
40 of them.
I mean, they're kind of fun.
It could be fun.
Yeah, they are.
All right, next I need a longer straight edge because I created yet another point. Another point of intersection way out there. And if I line these 2 points up, because it takes 2 points to make a straight line, I'm going to draw a line through those, pointing right up to the coffee beans.
I keep thinking they're potatoes.
Potatoes.
Well, no, they look like potatoes at all,
I
right?
really don't.
And what, aside from the potatoes that we're apparently pointing at, what have we just done?
Bisected and labeled.
We
Bisected 100.
bisected this.
Are we supposed to label that?
So we bisected it.
Or no?
Or we just put 2 angles.
It just
on
says
top of it.
bisect XYZ.
Pizza.
So you can label this anything you want. What do you want to label it?
King.
Chamberlain.
Mars.
Emma Chamberlain?
Elon.
No, I just
Elon.
said Chamberlain.
This one.
No.
Chamberlain pot?
That's not a.
Oh.
What is that? Chamberlain. Chamberlain. Merlin.
Berlin Wall.
No, like
Okay.
Burlington coats.
Moving on.
Well, there was no requirement to label it, but you have a point out there because this is the thing you're creating is that ray that bisects this angle. All right. So we constructed an angle that was 100 degrees. We then created or constructed an angle that was congruent to it, labeled it XYZ, and then we bisected XYZ.
Yay.
Chelsea spelled.
And we're not even done. We're just on the first page, the first problem.
Wait, but how come they...
However, questions about what we just did.
Why did they put this on this page and then they interrupted themselves with a different page of something else?
We're moving on to a new topic at that point.
When you construct the angle for the first time, it doesn't matter how short or how far out A and C are.
Clearly not, because this one is way out there, and this one barely made it.
I thought it mattered because I was like doing it and it was way farther than my house.
Yeah, it's just when you go to create that arc, it needs to be within the bounds of the lines you made. So if you made your lines really long, you got a lot more room, you can make your arc. But if you made them short, then you have to make a smaller arc, and there's more room for error. When you're using the compasses that you have on paper, it only goes so far, and there's a certain area which it works really well. It stays nice and smooth, and it doesn't move around. You start getting too close with it, and it's almost hard to manipulate because you've got the pencil lead. You're just trying to use it. So a good distance is nice, but you get too far with it, and then it starts to create. Well, now it's stretched way out, and you're trying to use a compass that's way out like that. So finding a good sweet spot, you can draw them whatever works for you and whatever works for your compass. Right, the next page we've had a whole host of properties. You have a lot of properties that you're supposed to be able to look at and memorize. That's why I was entrusting you with the homework of reading over page 22.
I don't
If you
know.
happen to take the extra step of converting committing to memory, page 22, that would be great. Maybe you translated it into another language that you speak.
Translate it into Minecraft enchanting table.
Good.
No one can do that.
So
Only not
the review page is the next page. Did you do that?
Yes, I did.
Okay, so for number 2A, it said using blank, add 1 to both sides. So you're looking over to the right.
It said adding, addition.
I put subtraction. But I don't think that's right.
How did you put
Because
subtraction?
none of the other ones.
Anyone want to vote for subtraction?
Using
Anyone want to vote for division? Anyone want to vote for addition property? Okay, we got a couple of votes for that. I would also vote for addition property.
on A? 2A.
Yeah, you can add the same thing to both sides of an equation and it doesn't change the value or the outcome of the equation.
Addition property.
That is the addition property. You can add the same thing to both sides. In just a moment we'll find out what is the subtraction property.
That's what you subtract.
The opposite.
So using the blank, multiply both sides by 3. What property do you think you would use to multiply both sides by 3?
Multiplication maybe.
Multiplication property. Okay.
Just a wild guess. Okay.
Alright, now we're on number 3A. Using the blank property, subtract 7 from both sides. What property do you suppose that is? The subtraction property.
Ah, I got it right.
Using the blank property, multiply both sides by 5 to remove the denominator.
Multiplication.
But it's still multiplication, even if you have a goal. Hopefully when you use one of these properties, you actually have a goal. You would want a goal.
Pass the test.
You could do any of these to an equation at any time, but the question you want to ask yourself is, was that helpful? Did I have a goal in mind when I added 1 to both sides, or subtracted 7 from both sides, or multiplied both sides by 3, or divided by 7?
Yes, that would look good.
My goal is becoming Justin.
Your goal is help. You need to move forward with purpose. So that's what these would do for you. So that's why they added in that little step. You multiplied both sides by 5, but you did that to eliminate the denominator. That was your goal. You could multiply both sides of that equation by 7, but that wouldn't help. You'd just end up with a bigger mess. And you'd still have a 5 in your denominator. Now if you multiply both sides by 25, that would help, but then you'd have a bigger problem, but the 5 would be gone from the denominator. So the key is, what's the lowest common multiple, perhaps, that's the word you might use or consider. What can I do to be helpful? Alright, moving on. Using the blank, divide both sides by 3 to remove the coefficient of x.
Division property.
Using division. So what is the coefficient of x?
3.
3.
4.
Close. Well, that never.
It's not really, you look at the problem that's there on the page. It originally was 3x equals 30. So if it's 3x equals 30, what's the coefficient of x? That's the number in front of x. So that number is being multiplied by x, and x is being multiplied by that number. So that's called the coefficient of x. Number 4, A. Now the instructions though were using 2 equations, solve for x and y. So using the blank property, add these 2 equations. What property would that be?
And addition.
Addition property.
That actually confused me. I'm embarrassed to say it, but that confused me.
Why would you say it then?
It did, the first one confused me because I didn't even read
It seemed like they wanted you to do a bit more than what was really being asked of you. Alright, let's try again for B. Using the blank property, divide both sides by 10. Division. Using the blank property, substitute 4 for y in equation 1. Substitution. Good. Using the blank property, subtract 24 from both sides.
Subtractors.
And then using the blank property, divide both sides by 3.
Divisors.
Okay.
It said divisors.
Division property.
Divisors.
Now there's a few more. There's properties of equality or congruence. And you need to reach the following results. So some properties are not used at all, others are used more than once, is what our instructions say. So if 4 plus 8 equals 12, and 12 equals 17 minus 5, so those are written there for you on your page, number 5, page 24. Then, so we have an if and then statement. If then statement. Commonly used in programming, commonly used in geometry.
You say you to programming? I said you to geometry.
Geometry and programming.
I said you to geometry.
So then, okay, so 4 plus 8 is 12, and 17 minus 5 is 12. They just wrote it backwards. Kind of gets your brain thinking, oh, okay, so they're both the same. What property is that? When you take two things that are equal, so this is
Equality.
this is an if A equals C and B equals C, or maybe I could say C equals B. Then what?
Then
Would it be
A
B
equality
equals A or
No,
congruent?
A equals B.
B equals A.
A equals B.
D equality.
A equals B.
A
Yes.
equals B. What is that?
Equality.
Maybe.
Property.
Congruence. Congruent? Yeah, congruence. It's property of congruence.
Transitive.
But it's a S.
Transitive.
Why?
Because you're making the jump. You have from here to here, here to here, therefore here to here. So there was no way to bridge this. There was a giant river flowing between A equals C and B equals C. There's A equals C on one side of the river and B equals C over there. Like, hey! And then you need to understand, well, A and B would be the same. If A equals C and B equals C, then A would equal B. That's transitive. Next, if x minus 13 is 1, then x would be 14. You understand that, I hope.
Yes.
But what property tells us that that's true?
Subtract. No idea.
Well, the question would be, I need to either think through that or actually do it.
Would be
So if x minus 13 equals 1, they already gave you that answer.
so it's just one.
Now, what did I do in the middle to get there? I added 13 to both sides. So what property did I use?
Reflexive.
Addition.
Got it right.
You got played.
Addition. Because the step I took specifically was adding 13 to both sides.
Next one
That makes
also
it addition. The next one is x plus 4 equals 12. So, much like here, if this said x plus 13 equals 1, what would I have done?
Addition.
I would subtract
Subtract it.
13 from both sides. In this case, it's x plus 4 equals 12. So the x plus 4 equals 12. So what do? I subtract 4 from both sides to get not 14, but what?
1. Wait.
13. No.
8. It gives you that. You're not actually doing that math. But hopefully you can take 4 away from 12 and get 8. But the property that I used happened right here. That was the subtraction property. Number 8. 7x equals 42. What do I do to both sides to get x by itself, to solve for x? They already told me what x is. X is equal to 6. How did I get there?
Division property.
I divided both sides by 7, so therefore that is the division property. Number 9 is which property?
Multiplication.
Multiplication, because I multiplied both sides by what?
3.
3. Because I wanted to get rid of that
Denominator.
denominator. Yes, I did. Okay, number 10. Number 10. What's your guess on number 10?
Transitive.
Now, is that no, it's not. It's called.
That's transitive, isn't it?
No, it's.
Or reflexive.
Is it? Yeah, it's transitive.
Oh no, it's transitive. Yeah, that's what you did earlier.
It looks like what we did earlier. If we have an A equals C and a C equals B, then I can say A equals B. this case though, in place of the A, B's, and C's, they give you angles. If angle 1 is not equal but congruent to angle 2, and angle 2 is congruent to angle 3, and therefore I can say angle 1 is congruent to angle 3. I already knew it was congruent to 2. I know that 2 is congruent to 3, therefore 1 is congruent to 3. This is transitive, right? That's a helpful property. It's not reflexive. If I had intersecting lines, and then I labeled these, let me make sure I labeled them correctly here. So 1, 2, and then I had more intersecting lines, and I wrote 3 here.
I don't get what you're saying.
I'm seeing that 1 is congruent to 2,
And 2.
2 is congruent to 3, so therefore 1 is congruent to 3.
Get it?
If I had a 4 right here, I could also say 3 was congruent to 4 based on what property?
Transitive. No.
Reflexive.
Reflexive.
Yeah. So that's the difference. These are reflexive, and 1 to 2, 2 to 3, 1 connecting 1 to 3, 1 to hold their place, that's transitive. But if they just reflect across from each other, then that's reflexive.
Then 11 is reflexive, right?
No, it's substitution.
Yeah, that one they are in fact substituting, yes. It would be helpful at this point if there was an example on this page that the answer is actually reflexive, but there's not one. But this one should help us. The way I just drew this out is where it becomes practical in geometry. It isn't just simply memorizing the properties. You'll use those properties to prove these kind of things. You'll be doing this a lot. Now, often they're connected. I'll wait for it.
I just carved the pine tree into the
Oh no, I would plug my ears for that.
All right. So
Doesn't.
maybe it's like this. And this is maybe line A, and this is line B, and this is C. So you're given that C intersects lines A and B. And you'll also be given, hopefully, that A and B are parallel.
That does not look parallel.
Well, you have to use your imagination, because I just drew it.
Fine, close.
And then you may end up with some of these. So this is 1, 2, 3. It's probably labeled like that. 1, 2, 3, 4. And then that would be 5, 6, 7, and 8. And then you'd be able to understand some things based upon, hopefully one of these would be given. Hopefully they would say angle 4 is congruent to angle 8.
I mean, if you could change to any of them you want, right?
And then from that point, you would be able to prove 4 and 8, 3 and 7, 1 and 5, 2 and 6, 4 and 2, 8 and 6, 7 and 5, 1 and 3.
Like reflexive properties.
Using reflexive and transitive.
What?
So, all right, what about 14?
Wait, what?
What property is that?
We're skipping.
Yes.
If m angle ABC equals m angle 1 plus m angle 2 plus m angle 3,
Then would that be
what's the question?
What property is that?
Question.
the addition property? No.
That would be
Transitive?
That would be
The whole is equal to the parts?
partition.
Partition, yes.
Where is that?
It's in the brains. They definitely memorized it for sure.
It's on the page. Not one you'll use a whole lot necessarily, but it is helpful to understand that the whole
Spell that.
is equal to the sum of the parts. That will be played out more practically in the situation where you have an angle and the angle is divided into several angles, and you have 1, 2, 3, And you might be able to write that angle 1 plus angle 2 plus angle 3 would be equal to some whole thing. So maybe this whole thing would be A, so it would be angle A. That kind of thing, which is very similar to the example they gave you, actually. They just put the M in front of it. What does it mean when the M is in front of it?
It means
Perfect things.
M is multiplied by it.
Yeah, what does it mean if there's an M in front of it?
I don't know.
Probably measure.
So you read that as the measure of angle 1. If it says M, angle 1, you would read that as the measure of angle 1. Just another way of identifying that angle. But more specifically, you're focused on what is the measure of it. Measure of angle 1. All right, next page. Check up.
Catch up. Yay.
Oh dear.
What?
We're done.